Walk through the woods, and the ground usually looks like a blur of green and brown. We step over fallen leaves and dead wood, passing over entire ecosystems operating at a scale most of us never notice. Within that leaf litter is a complex kingdom of fungi. These organisms are highly specialized, ranging from those that produce lethal toxins to the ones we rely on for life-saving medicine. A single walk reveals a range of bizarre structures, each breaking through the soil with a distinct physical form. The forest floor is an active biological map. To navigate it, you have to look past the surface and recognize the specific markers that define each species. With thousands of species existing simultaneously, the challenge is simple. How do you distinguish the common from the rare, or the harmless from the deadly? It begins with macromorphology, observing a mushroom's physical traits to understand its classification and role in the environment. This process uses physical characteristics as a filter. By checking for gill structures, cap textures, or the presence of a stem ring, the list of possibilities narrows until a single result remains. These traits explain more than just a name. They reveal how the organism lives, feeds, and interacts with the trees around it. In the dampest leaf litter, certain mushrooms stand out due to their stark, pale color. This cap is paper-thin. It is translucent enough that light passes through, revealing delicate internal structures. Running from the yellow center to the edge are deep radial grooves. These pleats allow the cap to expand and contract like a small folding umbrella. These specific traits identify the fragile dapperling, Leucocoprinus fragilissimus. It is a primary decomposer, responsible for recycling the forest's fallen organic matter. This structural fragility is actually an energy-saving strategy. The mushroom builds a structure just strong enough to release its spores before the entire cap dissolves back into the soil. Some species are much harder to miss. This massive, pale cap dominates the local area, but its identity is defined by the patterns on its surface. Notice the distinct, dark, broken scales on the cap. They are heavily concentrated at the center and become sparse toward the edge. A few yards away, a much smaller, dome-shaped mushroom appears. Despite the difference in size, it possesses a nearly identical arrangement of scales. The larger mushroom belongs to the chlorophyllum genus, while the smaller one is a young Lepiota. While they look similar, the stakes for misidentification here are high. The Lepiota family includes several species that contain lethal concentrations of amatoxins. Recognizing a shared visual pattern like these central scales is the starting point for identification. But distinguishing between two closely related species requires looking for even smaller, more specific variations. On the toughened surfaces of dead roots and logs, the morphology of the mushrooms changes to reflect the harshness of their environment. This species is defined by its stem, a dark, highly polished reddish-brown structure that feels more like wood than flesh. The cap shares this lacquered, almost plastic-like texture. It is rigid and tough, standing in sharp contrast to the delicate species seen earlier. This is a species of Ganoderma, commonly known as reishi. It is a saprotroph, meaning it gains its nutrients by processing dead wood. Its woody physical traits are a functional necessity. To break down dense hardwood logs, the mushroom requires a high level of structural integrity that soft-fleshed fungi simply don't possess. A single walk reveals how diverse these strategies can be, even within a few square yards of the same trail. This golden yellow cap, with its deeply wrinkled surface, is characteristic of several forest boletes. These dense, stark white clusters emerging from the soil are likely a species of Leucopaxillus, and these small, flat, orange-brown caps growing among the pine needles are typically Leucaria. In one small patch of woods, dozens of different species are operating simultaneously, each using a different physical design to survive. Once you begin to recognize these patterns, the forest floor changes. What was once a generic layer of dirt becomes a visible map of biological function. Observing specific markers, the texture of a cap, the arrangement of scales, or the rigidity of a stem, allows you to see the invisible networks that keep the forest healthy. Visual observation is the best way to appreciate this kingdom, but it is never a substitute for an expert's advice if you are considering foraging. On your next walk, look closer at the ground. Each mushroom is a visible sign of massive life cycles taking place just beneath your boots. To continue exploring the hidden systems of the natural world, subscribe for our next investigation.